Hello everyone. In this video, let's learn about the SR flip-flop. So first, let's have some background. So flip-flop is a sequential circuit which works same exactly as latch with only slight difference. In latches, as we saw in previous videos, the output changes immediately when the input is changed. However, in a flip-flop, the output changes only on rising edge if flip-flop is positive edge triggered, or on falling edge if it's negative edge triggered. Positive edge triggered is whenever the clock goes from 0 to 1, and negative edge triggered is whenever the clock goes from 1 to 0. So the main idea of flip-flop is that the input can be changed at any time, but the output occurs only at edges, either falling edge or rising edge. So this way we can make our system synchronous. So let's see the symbol for the rising edge SR flip-flop. So we can represent it by a little box, and we have two inputs, S and R for reset, and then we introduce the clock. So when we have a little triangle here, this is the rising edge SR flip-flop, and then we have the same outputs. We have the Q state and we have the Q bar state. So this is rising edge. And also for the falling edge, it'll be very similar symbol. We have S and R. We have the clock, but we represent it. We add a little bubble here and a triangle, so we know this is falling edge SR flip-flop, and we have the same outputs, Q and a Q bar. So this will be falling edge. So if we want to see the circuit inside this symbol here, so we can draw SR flip-flop in two ways. We can use two NAND gates like this here, and then we will have, this is our S input, R input, Q and a Q bar, and this is our clock. And also we can use two NOR gates and two AND gates as shown here. So the truth table will be very similar to the latch. So we have S input, R input, and we have the next state that we have to figure out. So when S is 0 and R is 0, so we hold the previous state. If S is 1 and R is 0, so we set Q to 1. We set the next state, but only after the active clock edge. When S is 0 and R is 1, we reset Q to 0. Also same thing after active clock edge. When S is 1 and R is 1, we have the not allowed. So now let's take a quick example on the rising edge, how we can obtain the next state, and then also we can do the same thing on the falling edge. So let's take the following timing diagram, and let's figure out the next state. So let's assume this is a rising edge flip-flop. So where we have rising edge on the clock, we have it in this area where the clock is going from 0 to 1. We have here rising edge, and we have in this area rising edge. So let's draw a dashed line here, and then similarly here, and then similarly at this rising edge. So now let's figure out the next state, Q. What will be Q? So in this area here, we have a edge trigger, positive edge trigger. S is 1 and R is 0. So looking here, when S is 1 and R is 0, so we set the Q to 1. So from here, we will have, assume we start at the current state, Q is 0. So here we have rising edge, so we can go to 1. And then it stays 1 until the next edge trigger in this area here. So what happened in this area? So we look at S and R. So S is 0 and R is 1. So S is 0 and R is 1, we reset the Q to 0. So here we will go back to 0. And then it stays 0 until the next edge. So at this edge, what's happening? So we look at S and R. S is 0 and R is 1. So S is 0 and R is 1, we reset the Q to 0. But it's already 0, so it stays 0. So we can continue with the Q0. So this will be our Q. So next, let's draw Q, but let's assume it's falling edge. So we have falling edge in this area here. The clock is going from 1 to 0. We have falling edge here. And that's it. So let's draw a dashed line. And now let's draw Q, assuming it's negative edge triggered. So we start assuming the current state is 0. So we remain 0 here. So in this area, we have a clock edge trigger. So now we look at S and R. So S is 0 and R is 1 in this area. S is 0 and R is 1, so we reset the Q to 0. But it's already 0, so we keep it 0. We keep going until the next negative edge triggered. At this negative edge triggered, what's happening? So S is 1 and R is 0. So S is 1 and R is 0. From our truth table, we set the Q to 1. So now we go from 0 to 1, and then we stay 1 until the next negative edge triggered. So this is a Q, assuming falling edge triggered, and this was assuming rising edge triggered flip-flop. So that's it on the so that's all on the SR flip-flop. I hope this was helpful. Thanks for watching.